Hello and welcome to Greiner by One Talks. My name is Anna Maria Šimundić, and I'm the Global Director for Medical and Clinical Affairs at Greiner by One. And we will be talking today about digitalization and automation in Preanalytics. And I have a pleasure to welcome my guest for today, Henk Ruven. Henk is working at Antonius Hospital in Utrecht, the Netherlands, and is very enthusiastic about improving healthcare for patients as well as healthcare workers. So I think there is no better person to talk about digitalization and automation. Henk, welcome.
Thank you, Anna Maria.
So let's start with some general discussion about, why digital in Preanalytics? Where is the role of digital solutions in Preanalytics? What are the areas where, we still have some unmet needs and gaps? And how do you see the role in digital solutions in there?
Yeah. Well, okay, there is a lot to say and to tell about digital Preanalytics. But the most important thing is that we know that most failures, mistakes are made in the pre-analytical phase of lab testing in lab medicine. So this analytical part, we are pretty good in it compared to the pre-analytical part. So if you can optimize the pre-analytical phase, that will improve your total process, and it will reduce failures. But many people, we talk about digitalization. But what does it mean, digitalization? If you ask a random person about digitalization, then they think, should be something with iPads or mobile phones or something like that. So the first thing is digitalization means that you are not going to use paper any longer. That's it. So every laboratory, every hospital should try to remove all kind of paperwork, because those are people, healthcare professionals, they have to fill in papers and everything. So digitalization primarily is reducing errors, human errors, they will occur always again, but digitalization is reducing errors by using other methods and excluding critical steps in procedures.
Exactly. Yeah. And then when you combine digital with automation, then you actually remove human from most critical steps and reduce the error frequency.
Yes. Yeah. So automation has more to do with putting specific equipment in place, which is immediately used on the patient, or it is used in the laboratory for analysis. So digitalization is more about ICT software, kind of programming, maybe also data science, AI, or whatever. And automation is about, for instance, more or less...
having an instrument doing what a human was doing before. Yes. Replacing humans with instruments. Yeah. So when you look at Preanalytics from the patient preparation and then all steps until, the sample gets to the analyzer, what are the areas where you think digital solutions are still not present and where they would significantly reduce the error frequency?
Yes. So the two main areas are patient identification and tube how do you call it? Tube labeling. Tube labeling, but also so a blood collection from the wrong patient, the other patient who has the same family name or the same birth date. It's still happening during blood collection. So the identification of the patient is still a step we need to optimize.
Okay. Sorry, you told me that you are, when we were preparing for this talk, that you're a lead assessor for ISO 15189 for Dutch Accreditation Council. So let's maybe start first with the regulatory framework. What does ISO require for patient identification and tube labeling?
Great question. So I think especially this new version of ISO 15189, if if a laboratory tries to meet all the requirements of ISO, then they will have to think about all steps in pre-analytics. So all requirements are there. So, but you need, but the way you want to meet the requirements, it's free for a laboratory to find a way in it. So if you decide, well, we have to identify the patient, you can do it in several ways. You can use barcodes, which is quite digital, but you can also use just ask the patient. So what's your name, what's your birth date, to check whether it's the right patient. So ISO gives you a lot of room to fill in the specific way, specific patient groups to meet the requirements of that.
Yeah. So it's not as prescriptive maybe as it was in the past.
Yeah.
So ISO actually requires that while collecting the blood from the patient, there has to be a way to make a record of the person who did the blood collection, of the time of the blood collection, of the identity of the patient, and then also to ensure that the tube belongs to the patient. Time of blood collection, I think, is still a big challenge, right? And there was a study published some years ago showing that 50% of the labs in Europe still are not able to keep record of the time of blood sampling. Can we discuss it a bit more?
Yeah, I totally agree on that. And a lot of hospitals and labs, there is no description, no time of blood collection in the databases in the LIS. Well, simply because a lot of labs still work with paper, in which the phlebotomist signs the paper. Well, I've performed the blood collection at this patient, but the time of blood collection is not recorded. So that's and well, we all know ISO requires that you register the time of blood collection. So there you have your first digital solution, and there are several solutions for that. But digitalization will make it possible to register time of blood collection. But it will also make it possible to register all other kind of things. So you will immediately get registry of what kind of tubes are collected.
Exactly.
In which order. Maybe there are some specialties there, some special circumstances around the patients, and they can be immediately registered by the phlebotomist. So it will help the phlebotomist to focus, to more focus on what is really important, and that's the venipuncture itself and having contact with the patient. That's very important. So yeah.
So for those hospitals where time of blood sampling is not available for the lab or not accurate, actually what the time of collection means is, or let me say it in another way, for hospitals where time of collection is not available, actually the time of collection is the time when the tests were requested by the nurse, right? And that is not the time of blood collection, because the blood collection may occur hours later. So my question to you then is, why do we insist so much on time of blood collection? And I guess it's because of sample stability, because ISO also requires that you assess the sample acceptance criteria, that you ensure that the sample is stable enough to perform testing. So how do you do that if you don't have time of collection?
Well, in my hospital, so the time of requesting, the time of ordering the lab test is not the time of collection. So we do have, now we have everything in place. So we register every time of collection. But a year ago, we still had in the morning round in the hospital, all the collections were set on 8 o'clock in the morning. But the collection could be at 8:15, 9, 10, 11 o'clock. So there is more or less a time span there of about 3 hours.
Yeah.
And sample stability, sample integrity, it's also an ISO requirement, but it's also really necessary to perform a good analysis of your in your sample. So you can just add this 3 hours margin on the total time of sample stability. So it is possible in some way to correct if you do not have the right sample time. It is possible, but it's not ideal, of course.
Yeah. Yeah, yeah. And for some critical analytes, maybe it's not appropriate.
It's not. No. But so digitalization is really the solution for this problem.
Yeah. So can you explain maybe the solution you use in your hospital, and what improvements did you make in order to meet the ISO requirements in terms of time of blood collection, patient identification?
So at this moment, at some wards, so we started with this. So we use what we call we call them cows. It's cows, and those are those trolleys with everything on it and in it and everything. I'm from the Netherlands, so we call them cows, especially not. And so now we are able to register the right blood collection time because the phlebotomist has the PC just next to the patient.
So it's also for nurses at the clinical departments, or is it just for outpatients?
It's not for the nurses. They still have to send it another way. Yes. Yeah.
Okay.
Yeah. So we started with the phlebotomist of the laboratory, but it's not implemented in the whole hospital. Not yet.
Okay.
Yeah.
Okay. So we talked about sample stability, and that leads me to my next question, and that is sample transport. So ISO also requires that you monitor transport temperature, time and temperature conditions during transport, sample transport.
Yeah.
And when we think about transport, it's not only the transport from the patient bed in the hospital to the lab, but it sometimes can be hundreds of kilometers and under various temperature conditions. So what is the demand there, and what do you think are the gaps and possible solutions?
Yeah. So within the hospital, the transportation of samples, it's going pretty well. So we have the pneumatic tube systems, and most samples go with the pneumatic tube systems. And there are a number of tubes which need to be brought. They're not allowed to use it in the PTS. So they're brought to the laboratory. So it's a pretty good process, not so much failures. But especially for the outpatients, so the areas in the region where samples are collected in boxes, temperature-controlled boxes, there are the challenges. So sometimes it takes a little bit longer, or sometimes it's winter or summer times.
Yeah.
So we do have a system in which we can read the temperature in the box once the box arrives at the hospital. We do a readout, and we know, okay, these were the right temperature, right temperatures in the box, so those samples can be analyzed. But actually, you are too late for that, because then the sample, if temperature was not okay, or it took a too long time, then the sample is already, or you cannot use it for
the
analysis.
sample is lost. The sample is already lost. And so what you are saying is actually that maybe a better, improved version of that solution would be continuous monitoring, where you would be able to maybe react upon the alarm that the temperature was over some setup predefined range.
So that will be a solution, that you have a continuous measurement, and that you get an alarm, and then you have to, you can, exactly what you're saying, and of course many times professionals, but also others say, well, then we do a new blood collection and we will resolve the problem if a sample cannot be used. But repeating this blood collection at a patient, it's not a corrective action or something, because you have to do the venipuncture again, the patient, but it's also another time point. So it's not so important for an outpatient or patient in which you can do the collection 1 or 2 hours later. But in the hospital, you want to have this material at a given time point. So that's why we need systems to get immediately an alarm if the transport conditions are not okay. Well, ideally, you want to have this alarm before the sample is not suitable for analysis anymore. So
exactly.
If the alarm goes off and then the sample cannot be used, then you are too late.
Exactly.
Yeah.
So when we talk about digital, going back to that transport box, when this box arrives to the lab, then what happens in your particular lab? Is there a person that needs then to check the box and then do some manual steps? Or in my view, the ideal solution would be then that you don't care about the box, you just put the tubes in the centrifuge, you process them, and the information about it is digitally somehow transferred to the LIS, and the LIS knows then, aligns this information or associates it with the tube, individual tube, and decides whether the tube is appropriate or not. So that for me would be the future, right? So that you remove the human out of it. What is the situation right now in your lab? And
so the situation is that most tubes in the transfer boxes are immediately put in the pre-analytical station. So the professional doesn't need to check those tubes at all.
Okay.
But they will check, of course. They will look to the condition of the tube, but they will not check what kind of tubes or are the tubes complete. It's all immediately placed in the pre-analytical station.
And the information about the temperature is also transferred to the LAS?
No. The information at temperature is a completely different system.
Okay. So then a human again has to check whether the conditions were met. And what happens if the conditions were not met?
Then the tubes will be taken out of the system, and we have to check. So what were the temperature conditions? Mostly a clinical chemist will be called, and we will see where it's still possible to do the analysis in those tubes, depending on the temperatures and the time of the temperatures.
So I see here a lot of involvement of humans still, a lot of manual steps. So do you see a room for, again, digital or maybe even artificial intelligence?
I think it's already quite very well in place, but I mean, it's still human work. So some boxes, some temperatures, they are not okay, but most of the time the process is well. But we need to. No, actually, I don't see very much room at this moment on that part. So we don't have to check the tubes on temperature. Maybe we can connect the information with the LIS. But if you have a different system and there is an alarm when the boxes arrive or before the boxes arrive at the lab, that will be fine. That will be fine. I don't see big risk there. No.
Okay, so that leads me to my next question, and that is artificial intelligence. So when we were preparing for this talk, you told me that your main interest is actually prediction modeling and using AI in prediction modeling. So could you tell a bit more about it? I think you said you have a project ongoing, clinical trial ongoing. Could you share a little bit about it?
Yes. So in general, AI will give a lot of solutions in pre-analytics, in laboratory medicine, in healthcare. So especially with the lack of employees and restraints in budgets, so we need new ways to work and to manage to take care for the health of all patients in a region, for everybody. So the challenges in healthcare are huge. And if you talk with people about capacity in healthcare and what's coming to us in the coming 5 or 10 years, everybody thinks, well, I don't know how we are going to resolve this problem. So there we need data science, we need AI. And lab results is they are the best data you need for AI. It's a number.
Mm-hmm.
Of course, you can also use text in large language modeling and everything. It will also be used in prediction modeling, but lab tests, especially if there are many lab tests, clinical chemistry, that more or less it's the basis for prediction modeling. So at this moment, I recommend that every laboratory, every hospital starts storing the data of your lab test. So the time of collection, everything, the results, reference intervals, to store it in a proper way in your database, in your hospital information system. So that those data are integer. So data integrity, that will be the topic in the coming years. So that the data are stored in the same way, and very importantly, that the data also can be retrieved from the systems. But we are very good in putting data,
producing data,
putting them in a system, but getting them out in the right way
and using them.
That's very difficult. That's very difficult. So, and those AI applications, especially in predictive modeling, prediction modeling, they will come in a few years. So, and we had some projects on that already, some pilots, and it's quite easy, and the algorithms are not so very difficult. These are neural networking, everything. But it's not my field of expertise, but that's really not the problem. But to implement AI, to implement prediction modeling in a hospital system, so that's a step we have to take in the coming years. And I'm really very enthusiastic about that. So there are some projects also in the hospital about prediction modeling. So if a patient comes at the emergency department, we have a project there that very soon, based on patient data and the first lab test requested, that we know what will be the journey of the patient. Will the patient be sent back home, or will the patient be in a hospital? Will it stay in the hospital? So most projects, they are really promising, but we need to make the step to that it's available in the hospital information system. So basically, the doctor requests. It's in the further future. The doctor requests lab tests. The lab tests appear in the patient's record, and there is immediately some kind of clinical decision support tool, which says this patient's age, conditions, lab tests. So it's most probably it's this and this disease, and most probably it's this is the future of the patient. This is the prognosis of the patients. So that's where AI comes into place, and it makes it also possible to, if you have your data available in the hospital, then it will also be possible to give the patient data from other patients in the same hospital. So it's a very local condition, because patients are differently treated. So yeah.
And where in particular in Preanalytics do you see the role for AI? And I'll give you one example. I've read recently that a hospital in Turkey had an AI solution that was used to optimize the patient workflow in phlebotomy unit. So the solution actually had a task to minimize the time of the patient waiting time and to optimize the number of phlebotomy stations based on the patient load, right? So it was a real-time management of the patient's flow based on some predefined criteria. And I thought it's really genius. So obviously AI can be used to improve efficiency in general in laboratory. Where in pre-analytics do you think is the area where AI will play a role within the next 10 years?
So so if we collect all this data and we have good data and we know what happens with those patients in these years. So if a patient comes over 5 years, then AI will give you the possibility to give a suggestion to the medical doctor. Well, this and this tests are needed for this patient. So
demand management, actually.
Only the tests which are needed for that patient will be suggested to the medical doctor or to the medical lab. So in pre-analytics, we will see that less tests are ordered because there is an AI tool behind it.
Yeah.
That's a big gain.
Yeah. So to optimize the number of tests ordered per patient. To reduce the unnecessary tests, but also to maybe increase the number of tests that are necessary but have not been ordered for some reason.
Yes, of course, because it's still that in many cases the tests which are necessary are not ordered.
Yeah, exactly. So it's not
still the case.
It's about under-diagnosing as well. Yeah.
But we need medical doctors to join in this AI. Progression. Of course, they want to, but it means that the medical doctor has to rely on the AI, on the clinical decision support system, which says, well, you have to order this and this and this test. A medical doctor thinks, well, I think I also need this one. No, what are you going to do? But so these kind of AI support programs are also necessary to keep quality in healthcare with an increasing number of people using healthcare, and so those are the solutions we need.
So I like what you said. Doctors may think, well, AI solution may limit me in a way because I think there is another test I need to order. So obviously, one of the barriers to the full implementation of the AI in the healthcare is at the personal level. Clinicians want to be independent in their decision-making process. So what other barriers in the healthcare do you see when we think about implementing the AI in everyday work?
The barriers are that a lot of people think, well, AI, it's a little bit scary. They are going to know everything about me. So there is a privacy issue there.
Yeah.
And data need to be protected. And that's one of the biggest barriers. But so those AI tools, it needs to be very clear what they are doing. That's a barrier we have to overcome.
Absolutely.
But I think it's just a matter of experience. You just have to start with it. And as a patient knows, well, the AI tool says, well, you don't need to come back for a next venipuncture. Then a patient thinks, well, that's great. I think I trust the eye because I don't want to have a venipuncture again. Whereas maybe now, a lot of doctors, also laboratories say, well, if you have this and this operation, you have to come back for a venipuncture. We have to check your hemoglobin and everything. So that's not necessary anymore. So basically, it's a matter of convenience. If AI gives you some convenience, then it will be accepted. But for the medical doctor, it's a completely different story. They are responsible for what happens to the patient. So I think they have the freedom to add some extra tests, despite the decision tool says, well, you don't need to do those tests. I think we have to keep that freedom. And it's also important in teaching hospitals, of course. Medical doctors need to know, they have to learn about tests, and they have to use them.
Yeah, I think you made a very good point. It's about, who is responsible. So
Yeah.
AI is a fantastic tool, but it's only a tool that we can use to improve efficiency or, the way we perform certain tasks. But the ultimate responsibility lies with the person that is responsible for that task.
And AI, it will be used in a kind of context. So so in laboratory medicine, we always talk about measurement uncertainty and the best test and everything. But we have to look to the lab test, the value of a lab test in the patient journey, in the whole clinical medical path of a patient. And I'm convinced that lab testing is very valuable. It's even more valuable than we think. So AI has to be put, so those AI algorithms have to be made of each patient group, every patient journey, and lab medicine has a place in such a journey, and that's how we have to approach it, instead of thinking only about the costs of a lab test, because the added value is much more than we think.
Yeah, absolutely.
Yeah.
So you invest in the lab, and then the real benefits will be visible somewhere down the line across the patient journey. So not necessarily in the lab area of the lab responsibility.
Yeah. And lab tests are still, and there will be more and more lab tests requested. And technology advances, so better analytical methods. We have the whole molecular diagnostics and everything. So it will be easier to generate more data. And they are figures, they are numbers. You can use them in the AI programs. And that's very promising.
That's really exciting.
Yeah.
I look forward to the next 10 years. So let's now talk about automation in Preanalytics. And I have to say, I was really impressed to learn that your hospital was one of the clinical sites where the clinical trial was just finished recently with the first, not the first, but one of the very first automated venous blood collection robots.
Yeah.
So tell us a little bit about it. Robots in blood collection. Is that possible?
Yes. So we were really happy that we could join this project and facilitate the company in doing studies with the blood collection robot. And the first time I heard about this collection robot, I'm not going to put my arm in this robot. Maybe it's terrible and everything, and almost everybody reacts in the same way.
Yeah.
We are not going to put my arm in a robot which sticks a needle.
Yes.
I mean, that's
scary.
And nobody there. It's scary. But now I'm not directly involved in the project. So some of my colleagues, clinical chemists, they know everything about it. But now I've seen the instrument, I've seen people reacting on that, people putting their arm in it, and it's convenient. Most of the people say, well, it's no problem for me to put my arm in a robot and do a venipuncture. And there are a lot of advantages for that. So, I want to share two of them. I just found it out a few days ago, but it's very important you don't see the needle going into your vein.
Many people are afraid of needles.
Yes.
Yeah.
I think it's natural to be afraid of needles.
I agree.
Of course, that's. But you don't if your arm here, then the system goes very gently like this, and you don't see the needle going in, and that's a big advantage for a lot of people. And the other advantage is that you don't see how many tubes are collected. Because I know from myself, if I have to do a venipuncture and undergo a venipuncture, it's one tube. Okay. Second one. I'm third one.
Yeah. I totally get it. Yeah.
So there are a lot of elements different compared to a venipuncture by a phlebotomist. Advantages and disadvantages. But the blood collection robot will be used by relatively healthy persons which have a busy life and chronic disease. They run into the ward and they stick their arm in the robot. So if you have diabetes type 1, for instance, every year or every half year you have to check your lab, and then you are busy, and then it's a great solution for them. Yeah.
But why do you think, what is the primary reason for these blood collection robots to be, placed on the market? Why do we need them?
Yeah.
What is the need?
The main drive is that we will not have enough phlebotomists in the future. That's where we anticipate on.
Yeah.
That's absolutely the main drive. For that.
Shortage of stuff.
Yeah. That's, and it will become more and more.
And more. Yeah.
Yeah.
So do you think that market will accept this? That there will be enough need in the market, that this will be the technology that will replace humans in the next 10 years or so?
No, there will not be a replacement. I think you have to give a choice to a patient.
Oh, okay.
Do you want to have a phlebotomy by phlebotomist, and you have a nice chat, and it's a human who prepares yourself, or you go to the robot? So I think we will always have a choice, and there are also particular patients which, you still need a blood collection by a human. So there will always be a choice there. But I think in the next 5-10 years, those robots will be everywhere in the laboratories and in the hospitals. Yeah.
Well, wouldn't you say that laboratory medicine in general is a bit slow in accepting robotic solutions, like, for example, this one? Because if you think about other disciplines in medicine, you have robotic neurosurgery, cardiac surgery for a long time, for many years. Why is that we in laboratory medicine are so slow?
I never thought about it. I think, are we slow? I think automation and robots.
Well, in preanalytics.
In preanalytics. Yeah.
And also the patient, sorry to interrupt you, but also the patient. You were saying, a patient needs to have a choice to have his blood taken by a person or by a robot. Do you have a choice when you go under, brain surgery? No, it's the doctor that decides, and there are many robotic solutions which are superior, much superior to human, because they're more precise, right? They offer standardized way of doing things.
Yeah. So
why are we, I think, still skeptical in accepting, welcoming, embracing the robotic solutions in preanalytics?
Yeah. So the technology is very refined, because you need a robot which performs a venipuncture 10,000 times, and it has to be very good. So no mistakes are made. So I think the blood collection robot needs to be an almost perfect instrument. It has also something to do with the venipuncture itself, because if you have an operation and
then you're sedated.
You're sedated.
Yes.
But now you're a human being, and they have to stick a needle into you. So you want to have other human being next to you who gives you confidence that it will go fine. And it's a metal needle. I think it's far underestimated how invasive and how important a blood collection is.
Yeah. I get your point. Yeah.
Yeah, and also because if you have a blood collection, there will be a result. There will be a result, and the result is very important for your future, always. If you measure glucose and it's 0.2 value above your reference interval, it's for myself also. I think, what's going on? That's so.
Exactly.
It's very important.
Yeah, absolutely. So we talked about digital solutions, AI, robots. And I think we already have so many exciting solutions out there. But now let's think about, what's there for us in the future. Let's think about the next 5 to 10 years. What do you think, in your opinion, what would be the major disruptive digital or automated solution in pre-analytics?
Yeah. So I think blood collection, if you think about it, is still quite a primitive action. So we collect large tubes, 2.7, 3, 5, 10 mLs, and we only use a few hundred microliters. And it still takes a very long time until the results are there. If I walk through a hospital, I hear, "Oh, we are waiting for the lab. We are waiting for the lab." Medical doctors telling, "We are waiting for the lab." Nurses waiting for the lab. So there's an improvement. So really disruptive will be sensor technology, in which you have a sensor sticking in your skin or in a vein, which measures immediately the analyte, the lab test, and which gives you a result immediately, and which sends the result immediately to the hospital information system. So that technology, which is not available yet on a large scale for many tests, but we have it for glucose, for instance.
Yeah.
That will be disruptive, because then you will have real-time lab results immediately. But it's not that far yet. Next, disruptive, also a lot of companies working on non-invasive lab testing. Of course, we have watches for vital functions, but if it's possible to measure the molecules non-invasively, that will be even more disruptive than the sensor technology. So those two, that will be the future. Well, third one, I think it's lifestyle preventive medicine. So now most people get a venipuncture and go to the doctor if they are ill or they're feeling ill. But in the future, we will collect lab results from individuals once they are healthy, when they're still healthy, and then you get a prognosis of your life. So, what are your risks? What are your chances? Well, that will be disruptive, and that will be the far future. And it's maybe not always great and pretty and everything, but I think a lot of people will be happy if they know, well, these are my potential diseases which I have to take care for, and then you can change lifestyle and everything.
Yeah, you're right, and I think you again made a very important point. It's we shouldn't forget that everything we do is in the end about the patient, about patient safety, patient needs, patient expectations, patient safety, right? So it's everything is about the patient. So when you think about,
I need to add to that, but I think we still need the blood collection. That's
yes.
New markers will appear in the acute setting, intensive care setting. Then there will be blood collection. So it will never.
It will remain.
It will remain.
But,
yes. Yeah.
But maybe the future will bring less painful blood collection, more convenient to the patient. Maybe not centralized in the lab, but in a patient's home, right? So. Again, it's the patient and patient needs who we need to think about, right? So, thinking about the patient, my final question to you is, in your career, what is the most memorable moment that you experienced from the patient perspective?
Yeah. Oh, yeah. So, if you talk about blood collection, pre-analytical phase, in my lab we have a lot of ladies, phlebotomists, and they take care of all those patients. They do the phlebotomies, and then sometimes people say, well, how long does it take? 3 minutes, 4 minutes? Can we go to even shorter? And, because of the shortage of staff and all kind of things. But if a patient comes in the hospital and goes to a doctor, and the doctor says, "Well, please, you go to the lab and do a phlebotomy." In several times, the first person a patient meets after the doctor is the phlebotomist. So there's the human part, and so I've seen patients sitting next to the phlebotomist and saying, "Well, I just heard I have cancer." So I think that's it's so important what we're doing there, and that's so impressive. So we must not forget that we are talking about human beings who want to be healthy, and it's very impressive that we have the technology of phlebotomy, which is sticking a needle in a vein, which is a very, in my opinion, very intimate medical
invasive procedure.
It's invasive, yes. And next to that, it's the human part. So, and we have to keep that. We have to keep that alive. So, and for me, every time it's impressive if I talk to the patients who are sitting next to the phlebotomist and tell their story. Yeah.
Thank you, Henk. That was really something special.
Yeah. Okay.
Thank you for sharing with me your, opinions and thoughts about today's insights, but also about some trends that are waiting for us in the future. So this was Greiner by One Talks. I hope you enjoyed it as much as I have.